everyone. I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, the topic we are going to discuss about partial differential equations regarding definitions and terminology. So, in the topic, first we will detail learning about definition of partial differential equation. Next, formation of PDE, that is partial differential equation, to form by elimination of arbitrary constants. Next, the same formation of PDE by elimination of arbitrary functions. The next one, Lagrange's linear equation, standard forms, and Charpit's method. This is regarding non-linear equation. First, the partial differential equations. An equation which involves one or two partial derivatives is called PDE. It must contain at least one dependent variable. Now, ours Z, which is playing the role of dependent, and two independent are there, that is X and Y. These two, they are playing the role of independent variables. Dou Z by dou X, that is partially the dou, the symbol which represents the differentiation, partially we are going to do. Here the numerator, the variable Z, dependent variable. The Z with respect to X, partially we are going to do differentiation. Dou Z by dou X, the notation we are assuming as P. The next one, dou Z by dou Y, that is partially Z with respect to Y, we are differentiating. It is denoted by Q. So this is first derivatives. The next, the second order, if you are noticing, these two, first order, that is we are finding the derivative only one time. The second time also we are moving. That is here the symbol, the dou, which has 2. So 2 times we are finding the derivative. So dou squared Z by dou X square, which is denoted by R. The next one, dou squared Z by dou X dou Y, which is denoted by S. So the last one is dou squared Z by dou Y square, that is represented the notation T. So P, Q, R, S, T. P, Q, they are related to first order, whereas R, S, T, they are concerned to second order. So now, what is the difference between differentiation and partial differentiation? So practically we can see that one. So now suppose in case the partial differentiation, to adopt that, how it is defined? Any variables, now xy is there. XY, they are playing the role of independent. Z is playing the role of dependent. So when we are concentrating X, Y should be treated as constant. This is the definition of partial differentiation. That practically what is defined, that we can see it here. with one small example. That is how our definition of partial differentiation it works. Now z equal to 2x plus y. We have taken some function 2x plus y. That is z which is defined in terms of x and y. So we are doing partially with respect to x. So when we are doing partially with respect to x, the left side is dou z by dou x. Whereas coming to right side, here the x differentiation is 1. 1 into 2, which is written here 2. The y completely, we are going to neglect it because it is another variable. We are not going to focus on this independent variable y. So it is treated as 0. The next one, the same treatment with respect to y we will give. So now when we are doing with respect to y, this is treated as 0. Now the y differentiation is 1. Here we can see it z square, which is equal to 2x square plus y square. This z square, we will do the differentiation. 2z, the z is playing the role of dependent. That is the reason z again, dou z by dou x. This point to be noted. Here, x square is there, which is 2x. Already to exist 4x. Whereas here, another variable, our concentration is towards x. What I circled it. Now, the y square which is treated as constant, so 0. The similar treatment if you give for y, that is partially we are going to do with respect to y. So this is 2z dou z by dou y. This is becoming 0 and y square, that is 2y. So here when we are concentrating x, y is treated as constant. When we are concentrating y, x is treated as constant. In these two cases, we have seen it, how the terminology of partial differentiation, which is subject to our differentiation partially. Now, the next one, our independent variables x and y under the operation multiplication, x square, y square. Now, this we will do partially with respect to x. So, z square. So, the differentiation is 2z dou z by dou x. Here, the x square is there. That differentiation is 2x y square. The same, here the question will come, before the two cases, the y square place we put it to 0. We neglected it. Whereas here y we are not neglecting. It is a good doubt. The reason is, even though it is a constant, but both the independent variables are put together under the operation of multiplication. This is the point very, very important in partial differentiation, the terminology which is connected to that. Now, that is the reason y square which is written as it is. Now, coming to with respect to y. So, do z square, 2z dou z by dou y. here x square, which is treated as constant, but we will consider it because they are put together combined with the operation of multiplication. Y square, which is 2y. So 2y x square. This is ordinary differentiation. So the formula, that is, suppose x square is it, n is playing the role 2, 2x, 2 power, that is power 2 minus 1. So here we have done it. This is the 3. If we have the doubt, how our terminology which is connected to it, like this, if we practice, we will be very strong in understanding the terminology towards our definitions, how they are and what basis they are defined. Yes, more, this bit, what is the function which will make us to understand the terminology of the definition, the terminology which is subjected to our definition of partial differential equation. This we have taken a log of b into y minus 1 divided by 1 minus x. Just we have taken this, name it as 1. This partially we will do with respect to x. So the full function, here is there our x. What to do? Remaining and all, which one we have to consider, which one we have to neglect it, that we have to see it now. So it is beautifully which is animated, that is the left side dou z by dou x, which is equal to the a which we have written as it is. Log of, so we know it is, suppose log x is there, we will write 1 by, what is that log, the term, we will be writing 1 by. So here, this 1 divided by, it should be written log of some term, that's it. So the sum term, 1 divided by to be written. 1 divided by, it is actually in fraction. So reciprocal, this which has come here, that we notice it here, this place. Now that term inside, that is there any x variable? Yes, here the x variable which is there. Before that, we have to do it. Here we can see it. So log x, 1 by x. So we have written reciprocally. This the top, the numerator, there is no x term at all. Put together under operation of multiplication. So this is written, the red color, the difference we made it. What I am circling, this one which has x term, that is 1 divided by 1 minus x which has the x term. That 1 minus x, the whole power minus 1, that is minus 1 minus x power minus 2, we can write it using the differentiation formula. This simplified format we have to write here. Again up to, so this we have done it for that part. Again this x, the differentiation is minus 1. So it's a very good function to understand the differentiation partially. the same one with respect to y. A log of some term. Yes, A as it is. So 1 divided by. So 1 divided by. This is our function. Yes, we have written reciprocally. Inside, only B we have to do. Sorry, Y we have to do it. The leftover constant, but we have to consider it. We consider it. The leftover, this part where it is Y. It is Y is there. The answer is 1. So, log of some term, 1 by that some term, the term which has that again the chain processing we have to write as a single line. We can write partial differentiation. This in detail, this problem which is done in a separate video with a complete solution. Our topic today is only the formulas, how they are defined. To define that, what is the terminology which is subject to that we are discussing. So the next one is form the partial differential equation. How to form? We are going to eliminate the arbitrary functions. So we can say it arbitrary function and arbitrary constant. Both, if we eliminate, we can form the partial differential equation. Yes. How this terminology which is going to work in our partial differential equation. Suppose some equation which is given, just we are naming as 1. In case suppose the equation is in this format, it is there. Our aim is we can do the starting only we discussed about the notations. PQ first order and RST second order, the notations we discussed in detail about it. Now here, either one time we can do partially or 2 times we can do partially. But finally this A and B, the constants should not be there. First, with respect to x we are doing. So if you do here with respect to x, we know the result. That is dou z by dou x, which is equal to A. The terminology we have to understand. Immediately, this notation already we discussed it. Dou z by dou x is nothing but P. So P equal to A. The same treatment we will give with respect to y. So dou z by dou y, the answer we are going to get B. This notation already, we know it, Q. So A we can remove it as P. B we can remove it by Q. Because this is the notation for P. This is the notation for Q. This terminology which is subjected to our to form the PDE by eliminating arbitrary constant. Here constant also should be added in the heading constant. Any problem whatever comes, such a way the terminology we have to subject to form the PDE. But one question, now first order we are doing, but still we are finding the constants are not eliminated, then we can move to second order. Is there any rule that is the particular given equation? So while solving, so the defined formulas when we are applying, the terminology which is subjected to that, when we have to go to the second order, it's a doubt which is ringing. So now, these are the notations. They are, with the aid of that, we will eliminate our arbitrary constant. Just we discussed here. Now we can see it one more. Suppose in case we know x, y, these two variables, they are playing the role of independent, whereas z is playing the role of dependent. We are counting the variables, independent variables. Suppose in our equation, we are counting the independent variables, how many are there? To eliminate the constants, how many constants are there? So we can see it here. The number of independent variables and how many constants we have to eliminate it. Suppose independent variables, the eliminating constants, they are more than the independent variables. Then compulsory, there is a chance to go to second order. There is a beautiful terminology which is connected to our subject, the formation of PDE. So we can see it here. This is the thing. X, Y, two independent variables, whereas A, B, C, three constants are there. So to eliminate three constants, but we have two independent variables. In such cases, the before one what we have discussed, we stopped. We did only first order. The constants are removed, what we discussed, the earlier one. Whereas now, two independent, but three constants, which will give rise to, which gives an indication that we have to move towards second order also. That's what which is written here. So these notations are very, very important. So completely eliminating the constants among these P, Q, R, S, T. Some relation also we will be getting among them. So now, so just what we discussed, that is eliminating arbitrary constant, we discussed it. Such a way we can, the terminology which is defined to form the PDE. Now, in this here, x, y, independent variable, z, dependent, what we have to do it. The terminology which is subject to this, what is that? Already we know the notations. 5 are there. P, Q, R, S, T. Anything. First order, second order. But finally, the F to be eliminated. This terminology which is connected to this to form the PDE. For that, the relations, the notations, the first order notation, P, the first order, dou z by dou x cube, dou z by dou y. The second order related ones, R, S, T. So now, to form PDE, eliminating arbitrary constants and functions, we discussed it. Next, we will move to Lagrange's linear equation. A linear partial differential equation of order 1 involving a dependent variable z and two independent variables x and y. So compulsory, it should have some form. Only linear equation, yeah, it's enough. Two independent variables, one dependent, we will call it as linear equation. That is, it should have the partial derivatives of order 1. What is a specifically Lagrangians linear equation? That is, it should have some specific formulation. That formulation is PP plus QQ, which is equal to R, where our PQR are the functions of, that is our P which is related to X, our Q which is related to Y, and R which is related to Z, which is called Lagrangians linear equation. So the format PP plus QQ, which is equal to R, we are calling as Lagrangians linear equation. In this, compulsory X and Y, they are playing the role of independent, Z which is playing the role of dependent. Now, this Lagrange's linear equation, that is the given equation which is in the format of PP plus QQ, which is equal to R. Then, two methods are there. That is, the first one is method of grouping, next method of multipliers. Yes. Now, what is the terminology which is connected to this method of grouping to define our Lagrangians linear equation? Suppose in case this is the some equation we have taken it. First we are checking it is not at all in the format of Lagrange's linear equation, because the format, the formulation which is PP plus QQ which is equal to R. First, this we have to do modifications are required to be in the format of Lagrange's linear equation. This is subjected, this terminology which is subject to that method of grouping. So, we have taken some formulations. This all in detail. Suppose this is there, the equations in detail, step by step, under animation. A separate videos are done under this topic, Lagrange's linear equation. Not only one video, two videos are done in detail, which is given in that. Here only the terminology which is connected to Lagrange's linear equation we are discussing. Throughout the video, definitions and terminology and question session regarding that. All this in detail, everything, the topic, the definition, separate videos are done. Now, the given equation, so this, we made it some simplifications to bring the Lagrange's linear equation format. Then, the Lagrange's auxiliary equations. The terminology, we are checking it is fit for Lagrange's linear equation. First, the answer is coming no. Then modifications, we have done it. Then the answer is coming yes, now it fits for Lagrange's linear equation. Then Lagrange's linear equation, what is the subject, the connectivity to define, to proceed further towards the required solution. This is the Lagrange's auxiliary equations are helping us. That is dx by capital P. This is small p, the next is capital P. This is Q, this is capital Q. This is playing the role capital R. So PP plus QQ, which is equal to R. We fit. Even the equation is not fitting. We made modifications. We made it to fit to our Lagrange's linear equation. After doing that, the Lagrange's auxiliary equations we have written here. So, and we are noticing three members are there here. Among the three members, any two members we can select. Here another question, on what basis, which is easy to interpret. If you are taking these two members, one solution will be getting. That these two, first and second member, u of xy, which is equal to some constant. Suppose if you're finding the second and third member, they are very easy to integrate it. Fine, we will take it. The result v of y comma z equal to some constant. No, better we will take third and first. Nothing wrong in it. W of z comma x equal to some constant. So any members among 1, 2 or 2, 3 or 3, 1, anything we can take it, we will find solutions from which we will be getting general solution. So first, to fit the format, the second, our terminology subject, auxiliary equations, among the numbers 1, 2, this is the solution we will obtain. Otherwise 2, 3, this is the solution, or third and first member combining, general solution we will be writing pi of u comma v equal to 0 or pi of v comma w equal to 0 or pi of w comma u equal to 0 respectively towards this. If you are taking this will be obtaining the general solution. If you are going towards this is the solution. So this is the terminology which is connected to the first method. The name is method of grouping. Already we defined the Lagrange's linear equation. Towards we will take our problem to get the solution. Next one, method of multipliers. What is the terminology related to that? Suppose this is given. So which is in the format of PP plus QQ, which is equal to R. Looking at the equation itself, we are easily able to tell. So this is P, this is completely capital P. This is Q, this is completely capital Q, this is completely capital R. So it is in the format of Lagrange's linear equation. So that's what which is written here. PP plus QQ, which is equal to R. So if it fits Lagrange's linear equation, the next we will move to auxiliary. So this is the auxiliary equation. So dx by, here which is written capital P, dy by capital Q, dz by capital R. Multipliers. Yes. That already we discussed a method of grouping. Multipliers, here I have taken x, y, z. And what basis we have taken the multipliers? Why specifically we have to take x, y, z? Why not x square, y square, z square, or x cube, y cube? Anything we can take it. So is there any, what is the terminology connected to our multipliers? That we will discuss now. That is the multiplication, how we have to do it. Here x, sorry, x is there, numerator and numerator, we will multiply it. Here we can see it, multiplied it. The second one is y. That is numerator and denominator we are multiplying. The third one is z. So numerator and denominator we multiply it. After multiplying, we will add this complete denominator and numerator we will add. So we added. When we are adding, we can see here this one and yes, this, and put together this, all are getting cancelled. The result is 0. The terminology which is related to our Lagrange's multiplier, the selection of this is whatever can be selected, but after doing the multiplication, this denominator 1, the result should be which is equal to 0, then we can integrate the numerator. So the numerator, when we are integrating, after integration, what we are obtaining, that is the solution. So this is the terminology connected to our Lagrangians multiplier if our given equation is Lagrangians linear equation, that is our format PP plus QQ, which is equal to R. Yeah, here we can see it. Suppose if you are taking the multipliers L, M, N. So here we know it, this is our Lagrangians auxiliary equations. So both here L multiply, M multiply, N we have to multiply. This is the way the multiplication to be done, and we will add denominator and numerator. Compulsory the denominator 1, we have to get 0. So the practically how the definition which is defined, that we discussed it here. Yes. Now, so far we discussed it, linear equation. There is Lagrange's linear equation under the method of grouping and method of multipliers. Now, standard form 1. Suppose if they are non-linear. So non-linear, that is the degree which is not equal to 1. Suppose dou z by dou x is there. This is first order, the degree also 1. Suppose this degree which is more than 1, then we will call it as non-linear. Now here we can see it, the equation which is of the form, that is f of p comma q, which is equal to 0. If it is equal to 0, whatever the equation which is given, the 5 terms are there, x, y, z, p, q. This is not any related to mathematical method, some sort of technique. We can have our own technique to remember the formulas. That is the way this is explaining. It's not related to any mathematical method. X, Y, Z, P, Q is there. The first standard form to remember, best way in the function, if it has only P and Q among these 5, we will select standard form 1. After selecting standard form 1, we have to follow the steps, the terminology which is connected to our standard form 1 to be followed to get the solution of a required equation. So first, that's what here which is written, the equations which has only P and Q. So then the solution is z equal to ax plus by plus c, which is equal to some, we have taken 1. This dou z equal to p, p equal to a. This we are understanding. This dou z by dou x, partially we have done it. This is the notation p. Here the right side, if you are taking, that is a, so which is equal to p. Same now, dou z by dou y. Here the answer is b. It's nothing but q equal to b. Yes. Now, how the terminology which is connected to our problems, we can see it now. This is our given question. This is our terminology. That is, given question, if it is in the format of P and Q, then the solution which is standard for this one. So for this is also standard. Then what I am putting, this, all this, the terminology, we are going to substitute in our given problem. So we are substituting in our given problem the complete, I am circling the terminology subject in our problem. Then after substituting, from which we will obtain what is b, that is this variable. That we will substitute in our the terminology, the related, the solution, then which is the required, the result of our given equation. Just now I will put the ticks now, which are the terminology connected one. 1, 2, 3. They are standard. Where the given equation is there, given, they are related to whatever the questions what we are asked to solve. If they have the variables p and q, remaining everything, that is the general terminology to be substituted, to be applied if the given which is in the format of which has p and q. This is the terminology connected to our standard form 1. Standard form 2, it has only p, q, z, x, y. Strictly it is not there. Then what are the terminology subjected to that? Z equal to f of u, where u equal to x plus ay. Then the solution of the given equation is p equal to dz by du, q equal to a dz by du. One, 2, 3, 4, all are related to our the terminology which we are going to substitute in our the given equation to be solved. After substituting, we will do the integration which will bring the result of our given equation. 1. This is the given equation. This all the terminology regarding our standard form 2 and integration, which will bring the result of this our given equation. If it is only it has p, q, z, it should not have x and y. Standard form 3, it should have p, q, x, y, z should not be there. Then what we have to do is, what is the terminology to define this standard form 3? That is xp, the terms put together we will group it. yq, we will group it another side. That solution we will limit as A. Solve P and Q. That is, we have to obtain the value of P and Q. After obtaining the value of P and Q, Z equal to P dx plus Q dy. These values we will put it in this equation and we will do the integration. 1, 2, 3. This is the terminology, standard one, which is defined if our equation which is in the format of this. This is the defined format of our standard form 3, for which this is the terminology which is supporting to that. After finishing all this, we will do the integration, which will bring the solution of our given equation. This is the way the connectivity it works in standard form 3. Coming to the point of standard form 4, the equation which is in the form of all the variables p, q, x, y, z, all the 5, they're playing the role. First, what is the step to be adopted? We will rewrite the equation, whatever which is given, but it should have. This is the defined one for our standard form 4. Z equal to Px, Qy and F, the combined P and Q it has. We will replace P by A and Q by B, which will bring the solution of our given equation if it has the format of this. This is the way the defined standard form 4 works. Standard form 5, the equation which is of the form. So far what we have discussed it, x is not having the power, whereas standard form 5, our x and y, they have the powers. The powers are m and n. Again, the m and n, for them separate rule is there. The rules are, we can see it here. Suppose the m and n, the values which are not equal to 1, we have to assume capital X and capital Y as capital X equal to small x power 1 minus m. Capital Y is nothing but small y power 1 minus n. If they are equal to 1, then capital X equal to log x, capital Y equal to log y. So, assuming assumptions to be done, after applying these assumptions, our given equation will be converted in such a way that is capital P, capital Q, Z, our standard form, which is reduced to standard form 2. We are going back from standard form, reducing the reduction of 5 to 3. After the reduction, we will apply standard form 2 conditions, a beautiful terminology which is followed in standard form 5. Standard form 6, that is here our z is having the power. Here also the two cases, we can see it here, the case 1, n which is not equal to minus 1. This is the assumption we have to take, that is capital Z equal to z power n plus 1. Whereas case 2, if it is equal to minus 1, then capital Z equal to log Z. Our standard form 6 to be reduced to standard form 3. Here we can notice it. First we will select whether case 1 or case 2, depending upon this n. After assumption, what we have to select is selected. Some steps to be allocated, mathematically some simplifications. Then our standard form to be reduced in the format of standard form 3. From there, standard form 3 rules to be adopted. So 50%, the standard form 6, the terminology, this is the terminology which is subjected to our 6 adopting, which is reduced to standard form 3. From there, the subject which is related to standard form 3, we have to adopting, we have to reach the solution of standard form 6, the defined one, to get the required solution of our given equation. Yeah, it's a one how it works actually, small steps which are given here. Here we can notice it here, p by x square is there and q by y square. If you are bringing this x up, that is x power minus 2, here also we can notice y power minus 2. So our m and n, they are playing the role of minus 2. So we can select the case m and n, which is they are not equal to 1. So this assumptions we have selected. And this comes under, that is f of p comma q comma z, which is equal to 0. That is, this is standard form 5 that we reduced it to standard form 2. Then two conditions adopting, we have to solve whatever the problems. So the defined standard form 5, these are the terminology that subject to that combined, finally we will get the required result of our given equation. These are the terminology which are this is standard form 5, which is reduced to standard form 2. So these are the conditions PQ, and we will substitute. Complete, this is the terminology regarding standard form 2. Here we can see it in the standard form 6. Here PQ, that they should not have power at all. So first, this is not at all in the format of standard form 6. To make the format, so first we are modifying. After modifying, z is having the power 1 by 2. So the case which we have to select it, the n which is not equal to minus 1, the case to be selected. For that, here we can see it here, f of pz power n comma qz power n. So the capital Z equal to z power n plus 1. Our n is nothing but 1 by 2. So now our standard form 6, which is reduced to standard form 3. The standard form 3, the condition is PQXY. that is the terminology, what are the formulations regarding standard form 3, which is px to be grouped and qy to be grouped, they are equated to a, and we have to find the value of p and q. Finally, we have to substitute z equal to p dx and q dy. Doing the integration, we will obtain the result of our given equation. So the complete the solutions, every separate video which is done. So now the non-linear, this is playing a very, very important role. That is the Charpit method. The Charpit method, a specific thing which is used to find the complete integral of non-linear partial differential equations of first order. That Charpit's auxiliary equations are, we can say it here, dx by minus dou f by dou p, which is equal to dy by minus dou f by dou q, which is equal to dz by minus p dou f by dou p minus q dou f by dou q, which is equal to dp by dou f by dou x plus p dou f by dou z. The final, the last, the fifth member, dq by dou f by dou y plus q dou f by dou z. So whatever the given the equation, if it is non-linear we know it, that is degree which is not equal to 1 of our given equation. These are the Charpit's 5 members are there. We will substitute this particular the values in their respective places. We can take any members, which is easy to do integration, and we will find the value of p and q. After finding the value of p and q, we will substitute z equal to p dx plus q dy, which is equal to z. We can see here a small example which is given here. Here this is the term which is z square minus pqxy, which is given. This is our Charpit's auxiliary equation. So here we have done it, this particular one, dou f by dou p, that is partially we have to do with respect to p. So the complete here, where is the q term is there? Here p we are doing. The p, the differentiation is 1 into qxy. This is the result we obtained. Similarly, here q we have to do it. Q is 1, so 1 into, so pxy. Z here is there, 2z. And x is here 1, the remaining which is written because they are put together under multiplication. Y is here 1, which is written. Everything the terms we are going to substitute in this particular places after substituting. We are taking the 5 members, this first and third member we are taking, that is multiply this both by up and down p, this by x. Anything we can take it. It's not a strictly we have to take a p and we have to take x, which is easy to integrate. So we have done it, we obtained one result. Same similar manner, we are taking other members. We can multiply q into dy. We will be getting same format. Both we will do equate. Our aim is we have to find the value of p and q. So this the terminology subject to our Charpit method. After obtaining the final, the subject, the terminology is d is equal to p dx plus q dy. The respective place p and q, what we obtained the values to be substituted. So now we will define the term partial differential equations. Now we will move to the question and answer sessions regarding partial differential equations, definitions and terminology. That is an equation involving partial derivatives of one dependent variable with respect to more than one independent variables. If it is there, then we will call partial differential equation. Describe the formation of partial differential equation. That is, a partial differential equation of any curve can be formed in two ways. That is, eliminating arbitrary constant and eliminating arbitrary functions. Write Lagrange's linear equation. That is an equation which is of the form PP plus QQ equal to R, which is called Lagrange's linear equation. Write auxiliary equation of Lagrange's linear partial differential equation. So the Lagrange's auxiliary equations are dx by p, which is equal to dy by q, which is equal to dz by capital R. Define first order equation. A differential equation involving partial derivatives. That is p and q only and no higher order. If they don't have higher orders, which is called first order equation, because we know it, p, which is a notation for dou z by dou x. Q, the notation is dou z by dou y. Write one example of linear Pde. That is, this is a small example we have taken px plus qy, which is equal to z. Because here, the first order dou z by dou x, dou z by dou y. So write the general solution of pp plus qq, which is equal to pi of u comma v equal to 0. Otherwise, we can write pi of v comma w equal to 0. That is, first x and y related. In general, default x and y, we will general solution uv. Suppose y, z, the default one, vw. Zx, we can write it pi of wu equal to 0. So define order of Pde. That is the highest partial derivative appearing in the equation. Write standard form 1. Yes, the function which has only p and q. Standard form 2, which has only p, q, z. Strictly x, y should not be there. Standard form 3, p, q, x, y, z is missing. Standard form 4, all the 5 are there. So here x should be there. Yeah, px plus qy. In such a way, it should be formatted. Px plus qy and pq. Standard form 5. X and y, they have powers. Compulsory p and q, the power should be 1. If it is not there, we have to modify the equation. This m and n, which is equal to 1, not equal to 1. That also we have to see. According to that, two cases are there. The standard form 5, standard form 6, z will be having the power. Here we can see. Here also two cases are there. Equal to -1, not equal to. What is a complete integral? A solution in which the number of arbitrary constants which are equal to number of independent variables. They are called complete integral or complete solution of the given equation. Define particular integral. A solution which is obtained by giving particular values to the arbitrary constants in the complete integral, which is called particular integral. So we will come to a conclusion of this topic. Partial differential equations. Definitions and terminology. Partial differential equations. Linear partial differential equations. Non-linear partial differential equations. What is PDE? We discussed it. One dependent, two independent variables. What is first order? PQ, first order. RST, they are the notations for second order. How to form the PDE? Eliminating arbitrary constant and functions. And we moved to Lagrange's linear equation. Linear, the degree is 1. PP plus QQ equal to R. The format of Lagrange's linear equation. Method of grouping, method of multipliers, the terminology which is connected to our Lagrange's linear equation of PDE, we discussed in detail how they are connected, how the terminology to get the solution of our given equations, whatever the equations which are given, such type of equations, the terminology, how which is connected to that in detail, we discussed it. Next, non-linear. It is regarding 6 standard forms are there. Standard form 1, what is the condition? What is the subject to that? Standard form 1, PQ, if it has some conditions are there. Standard form 2, PQZ is there, some conditions. Standard form 3, PQX1. Standard form 4, all the 5 are playing the role. Standard form 5, if that is x and y will have the power. If they are equal to 1, not equal to, some 2 cases which arise. Standard form 5 reduced to standard form 2. Then standard form 6, z will be having the power. Standard form 5 and 6, p and q will have the power strictly 1. If they have more, we have to modify the equations. This type of terminology which are connected to define our standard forms. Then non-linear, the specific method, Charpit method, the auxiliary equations we have taken, we substituted it among the 5 members regarding Charpit auxiliary equation. Among 5, anything which is easy to integrate. We solved it. PQ we found the values. We substituted in PDX plus QDY. Then after doing the integration, which is a required solution of our given non-linear equation. So the completely, even the initial stage, what is the difference? How to do the basic formula of even partial differential equation, which is discussed in this video lecture. In detail, the PDE, the complete knowledge will be gained in this through this video lecture. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.